theory and so on. This is what we calculated is the teeniest thing that the universe can do. It's 1.616 multiplied by 10 to the minus 33 centimeters. So you guys all understand exponents? You know, like if you 10 to the minus 33 means there's a decimal point, 33 zeros, you know. So it's very, very small. Extremely small. Billions of times smaller than an atom. So, do I believe this is the smallest thing the universe does? Absolutely not. However, I believe that this is the fundamental boundary condition that defines our relationship to the universe. That is, from our boundary condition, from our scales, this is the smallest thing we experience. So, they took that number and they said, okay, so how many of these little vibrations can I put in a centimeter cube of space? And that will give me a finite number for the density of space. You all following this? Good. Just making sure. So they made little vibrations of 10 to the minus 33 centimeters. They stuck them all in a centimeter cube of space. They counted them all. And since, you know, for a vibrational rate, you can get a mass, how much it weighs. The mass of the Planck's distance is 10 to the minus 5 grams. Then they added all the mass and got a density equation for the density of the vacuum. You all followed this? So this means that the vacuum, it has a density of energy of 10 to the 93 grams per centimeter cube. Yeah, that's what I thought. Now you gotta understand, 10 to the 93 is like a 10 with 92 zeros following it, right? Now you all notice in your bank account when you add a zero, things like, you know, improve very rapidly. You know, you got like 5 zeros and you add another one, it's like, oh yeah, this is good. Yeah, you know. Then you add another, oh yeah, I like it. Well, that's good. Keep going. Then you add another one, oh yeah, now I'm feeling good, right? So, imagine you got 50 zeros and you're still adding. So, imagine you got 50 zeros and you're still adding. So how dense is that? Let me give you an example. Yeah, I'm getting there. If you take a centimeter cube of space and you were to take all the stars in the universe we see with the largest telescope, billions of stars, right? There's billions of stars per galaxies. There's billions of galaxies. Most stars are much larger than our sun. Some of them are larger than our solar system. And we grab those, like quasars and stuff, and we grab all that stuff. We squashed it all into a centimeter cube of space with a huge trash compactor or something. Imagine how dense that would be. How energetic that would be, right? Well, you would still be off by some 39 orders of magnitude, right? Because you would have a cube of a density of 10 to the 55th grams per centimeter cube. So you'd be off by 39. You still need to add 39 zeros to get to the density of the vacuum, which is formally infinite, right? Do you think that the physicists that discovered this stopped and said, hey, maybe we need to consider this in our physics? No. They looked at that number and said, oh my God, it's actually called the vacuum catastrophe. It's like, oh, what do we do? Just ignore it, brah. That's if you're studying in Hawaii, you know. If you're here, you'd say, Ignore it, mate. Little translation for you guys. And, you know, all this energy just got pushed to the side and said, put under the carpet and said, hey, you know, this is too overwhelming. This probably has no significant physical meaning. Huh? You just found the most massive amount of energy ever, and you're saying it has no physical meaning? Most likely is the source of all physical meaning, brah. You know? If you're Hawaiian. And so, now you may say, maybe those physicists are insane. You know, how do I know that this is really there? You know, how do I know that these equations are just not like crazy equations? Well, because it was verified in laboratory. If you get two plates close enough together, you can push them together so that you eliminate the long wavelengths of the vacuum on the outside of the plates. And you retain only the small wavelengths in the middle of the plates. So the result is that there's more energy on the outside, less in the middle, so the plates should get pushed together. Professor in physics, Dr. Casimir, you know, came up with this concept in 1947. Should I play that again? And he thought, oh, that'd be a good experiment to put together. But in 1947, when he made the calculation, he realized the plates would have to be, you know, microns apart. In 1947, nobody could mill micron precision plates. So there was no way to get two plates that close together. It took until the 90s before we were able to do that. And then when we did, the plates pushed together exactly as Casimir had calculated they should push together based on the vacuum density, you know, that he calculated in 1947. So it's really there. Really, really there. And now physicists are more and more accepting that actually the fact that they're realizing the universe is not only expanding but it's accelerating is showing that the vacuum at the universal level might be the thing that's expanding our universe. Now, I know you've all heard from other presenters that the universe may not be expanding. When I talk about the universe expanding, I'm talking about the movements of planets, the movement of galaxies in our universe that appear to be moving away from a central point. Do I think that automatically means our universe is expanding? No. What I mean is that it could be moving away from the center at the equator, and it could be moving back towards center at the North and South Pole. And we wouldn't know. And it gets a little more complex and we don't have time to get into that, but we'll see some of the dynamics that produce that view. You know, we have a tendency to have an arrested view of the dynamics of nature. Nature is a little more complex than just a sphere. Just a little. And so, if this was true, then that means that our universe is driven by the vacuum, that the space between you and me connects us, that the information that is in the space divides in very specific scales, and those scales makes up all of our reality, and that we're part of those scales. You guys are following this? Instead of matter being some kind of entity that comes out of nowhere, matter is just the result of the division of the structure of space itself. And you are interacting with that structure every day, every second, every billionth of a second. We know that all the electrons and positrons in your atoms are going appear, disappear, appear, disappear, appear, disappear. in the vacuum. Every time the electron comes out, it's learning about your experience and then feeding it back to the vacuum, and learning about your experience and feeding it back to the vacuum. You are informing the universe. You are informing the universe about your specific point of view on the whole thing. And I can demonstrate that mathematically. And that's why people in the spiritual world are saying, you create your reality. Okay? The part that's missing in that statement is the other part of the feedback loop. A fractal is a feedback. The other part of the feedback loop is that reality is creating you. The vacuum is defining your existence. So, because you know what? If we all created our reality independently, we would never meet. It would really suck. We'd all be alone in our own little universe we created going, where did everybody go? We'd be really bored because we'd create exactly what we want every time and like, right? And so, but that's not what's happening. You're feeding information to the vacuum, and since the vacuum connects us all, it has the information of everybody in it, and it's feeding you back an experience, right, that's in coordination with everything else. So that there's a consensus reality. So that one being cannot overcome all the scales. So that one person cannot say, oh, you know, today I'm kind of hot. Let's turn off, let's cool off the sun. And then the poor guy in Alaska is like, dude, it's cold up here. Right? But there is scale relationships. So the idea of the butterfly analogy, right? The butterfly in Africa that bats its wings and it makes a hurricane in Florida, right? That's found in many literature on complex on the chaos theory. That concept is only true if you put it in the context of scales. You all following me? Like, meaning that if the probability of a butterfly flapping its wings in Africa producing a hurricane are really, really, really low. Actually almost non-existent. Why? Because it would suck. You'd have people in Florida going to Africa with shotguns going, brah! Don't you move those wings. Right? But maybe if you have millions of butterflies all moving their wings at the same time, now you got something going. Right? So the morphogenic field, we're all connected. If we're going to move forward, we got to bring enough oomph to the system so that it can modify. Right? This is actually why I talk to people. Right? We have to move together. It is a consensus reality. And it's really important for people to understand that, because then, first of all, you take responsibility in what you're feeding the vacuum. But as well, you realize that if it's not all going exactly how you want it to go, is because you're embedded in a morphogenic field and you're interacting with all the stuff that's going on.